2 month summer internship in IIT Madras under the guidance of Professor Suresh Rajan sir. To start my presentation, I would like to inform you that my task that was assigned to me at IIT Madras was to optimize the design procedure of a propeller. So to start with, I need to explain you a bit about propellers. The propellers are used to generate thrust for the ships and all. And at the beginning stages, we only have very limited information about the propellers that we are going to design. The information that we are going to have is only the diameter constraint that we can have in the propeller, and also the power generated by the engine, and also the required velocity we need the propeller to produce. Based on these three conditions, our task as a naval architecture is to design the most optimum propeller that we can give to a ship. To start you with, this is a basic propeller design. This entire section length is called the diameter, and this is the hub, and this is the blade. There are few very important parameters that every propeller needs to be designed on. Every propeller needs to be designed on. These parameters are the pitch angle. First, the pitch. What is the pitch? Pitch is the amount of axial distance a propeller travels in one full revolution. And then the area by area ratio. The area by area ratio is the ratio of the blade surface area to the actual circle area, and also the velocity at which the propeller needs to go, and also the RPM it needs to rotate with. These are the few actual things we need to keep our mind on to design a propeller. And now I am going to start you how I design this propeller procedure. The task that I have chosen is I am going to explain you about how I use Wageningen B-series propeller designs and their regression formula to make a Python code which directly takes in the parameters of pitch angle, area by area ratio, and the required velocity ranges, and it itself calculates the most optimum dimensions, and also gives a generated mesh file also with the help of the Python code that I developed. The formulas are all available in the Wageningen B-series paper that has been published in 1971. And by using those regression formulas, I made a Python code. This is the general outline of how I made the design procedure. This is the flow diagram of my procedure. What I'll be doing is, from the engine parameters, I already know the amount of power my engine is going to be producing. I also know the amount of torque that the shaft is going to produce. My job as a naval architect is to make sure that the propeller is turning with the same amount of torque and is producing the same amount of power with the help of calculating the power multiplying the efficiency values. So what I'll be knowing is, I know the power of my propeller that it needs to produce and also the torque. Basically, in the first stage, since I already know these values, I will have a starting point. From then onwards, I first assume a diameter in which I personally think might work. I'll assume a diameter based on empirical formulas or something, and then with the help of empirical formulas and with the help of regression formula, I will try to calculate the engine power, engine speed, and propeller pitch my propeller can have. But there's no guarantee that my assumptions are correct. So with these assumptions as a starting point, I'll make the code go into an iterative process where it iterates to various number of area by area ratios, pitch angles, and also the velocity ranges. By varying in these three parameters, it tries to find out the most efficient range of the parameter dimensions. When the iteration process is completed, it then finally checks if the amount of engine power is meeting by the amount of engine power I calculated. And if it's not calculated, then I will go change my diameter again and then run the whole simulation again. In this short process, this might sound short, but the entire iterative process takes something like 15 to 16 hours. And from all these processes, it kind of matches the best amount of pitch angle, area by area ratio, and the velocity ratio, and also the RPM at which the propeller is going to rotate. By taking the best optimum parameters from these four ranges, it will try to give the best propeller design that we can have for the ship. of this is basically propeller design used to take a lot of amount of time, and in most cases, if the propeller design is false or inaccurate.
What exactly you have done?
This is what my entire task is, sir. My task is to take the engine parameters and also the velocity I need to give to the ship and make it propeller design in this drawing file. This is all done with the help of code only. And for validation, what I've done is I've taken an open source tool known as Cases. They also have built a similar kind of code which can generate the propeller design with the help of engine parameters. And I validated my design with the Cases model, and I found out that the model is closely accurate, closely similar to them, apart from this tip regions.